So let's go a little more in depth on what some of these options mean while we're discussing dynamic cloth. If you're just joining us, you can just take this, double click this divider over here, and then take your dynamic menu, grab that white circle, and just drag it over here. Let's go ahead and start again with a plain 3D. Just drag it on your canvas, go into edit mode, and immediately come over here and hit make poly mesh 3D. So we have a 3D mesh. If you turn on polyframe over here, you can see that it's just polygons and there's just one single side. I'm going to go ahead and switch over here to Skin Shader 4 so you can see it a little bit better. And under the geometry, we have the new dynamic subdivision surfaces. We're going to turn on dynamic. We're going to turn smooth down to 0, and then thickness, we're going to crank that up just to give us a little bit of thickness. So if we turn our floor on, and we come over here to gravity, we have floor collision turned on, we run the simulation, it'll go ahead and simulate onto the floor. Now we talked previously about the difference between gravity and liquify. Essentially, if we turn off floor collision, and we rotate this, and we run it with gravity, we turn off the floor here, we just run the simulation, it's going to fall. If we turn on liquify and run the simulation, it's not going to do anything. However, if we go in here and we give the simulation something to calculate, essentially we're changing the relationships between these edges, and that's what this dynamics is all about. It's maintaining relationships between vert positions and edge relationships. So now we have liquify, we've given it something to simulate with, and now it'll go through. Let's go ahead and turn that gravity down, just strength down just a little bit so it goes a little slower. You're going to see it's going to start from those points, and now it's going to look like it's simulating through a liquid environment. Let's go ahead and undo back, turn our floor back on, turn floor collision back on, turn liquify off, and that's the basics of gravity. Now, before we start talking about iterations and strength and firmness and stuff like that, let's give this something other than the floor to collide with. It'll demonstrate a little bit easier. So what I'm going to do is go down here to append, and we're just going to grab a sphere 3D. And let's select the sphere 3D in our canvas, or in our subtool menu here. Let's hit E, or it's gizmo, so you can just hit W if you want to, and you can just grab this little scale uniform. We're just going to scale this down just a bit. And we're going to take our plane, select that in our subtool menu, hold down Shift, and rotate this so that it's going to basically be flat. And then we're going to move this above that sphere here. So now, when we have the sphere drop, it's going to connect. Or when you have the plane drop, it's going to connect with our sphere. It's going to use this as a collision volume. Now, we have to tell ZBrush that that's what we intend to do. Right now, if we run this, we have floor collision turned on, so we run the simulation. It'll stop at the floor. It's going to completely ignore that sphere. And in fact, let's make this a little more interesting. Let's take this sphere here, and we'll hit W, and we're going to Control drag out a copy. And this copy, let's make a little smaller. So let's kind of put this over here. And then Control drag, and that'll unmask our new collision volume that we have. So if we select the plane, that's going to tell ZBrush, I want to dynamically manipulate this surface, or these edges, or these verts. And everything else in my scene, I either want it to ignore, or if I come over here and say turn on collision volume, anything not selected and visible in my subtools here are going to be treated as a collision volume. So essentially what it's doing is taking these visible objects and turning them into a collidable object. So if I go through here and now I run simulation, it's going to go ahead and hit both of those objects and simulate around them. So now let's talk about gravity strength and speed in simulation iterations. So if we come up here and our default gravity is set at 10 and our default simulation iterations is set at 100. So if you just run the simulation, it's going to fall very quickly, and you can kind of see these are kind of getting stressed quite a bit. They're stretching quite a bit. In fact, if we crank up that gravity strength and run it, it may completely miss a collision volume altogether. It could go straight through it, or it could see it, but it's going to have a real hard time maintaining these relationships. This isn't very realistic or cloth-like. I suppose if you had a very stretchy, thin cloth, that would maybe be appropriate, but for most cloth, you don't really want to stress those relationships very much. And again, the relationships I'm talking about are these edge relationships. What the collision iterations and calculations and the algorithms are doing under the hood is trying to maintain the original relationships between these edges and these verts. And in order to give it enough time to calculate those relationships, as it's dynamically moving this through space, what you have to do is, number one, you need to slow the gravity strength down So if we put it down, let's say 1, and then we run the simulation, you're going to see it's going to have plenty of time to think about, okay, this edge is here, this edge is here, let's maintain those relationships. Oh, the collision volume is underneath, it's this shape, so I'm going to go ahead and it's going to hit the floor. So it's constantly running calculations all over this object to make sure that those relationships are maintained in a realistic way based on the settings you have dialed in. So one way to get a nice accurate simulation is to slow the gravity strength down so that it has plenty of time to make those calculations. Now another thing you can do is you can come up here and you can say, okay, let's take that gravity strength up to 10 again. There's also the simulation iterations up here at the top. If I crank that up to 1,000 and I run the simulation, it's still going to do a pretty good job. In fact, it ran pretty fast and it maintained those relationships just fine. And now that will, depending on the complexity of your mesh, that may slow your simulations down. It may have to go, hey, if you're telling me basically run 1,000 iterations of that cloth algorithm across the entire surface while calculating the collision volumes, while moving through space at 1,000 times per movement, I'm going to need more CPU horsepower in order to calculate that. So it's going to automatically kind of slow the simulation down. On something as simple as this, you're going to not notice it slowing down that much. So what I would suggest is it's kind of a combination of those. If you're losing those relationships, come down here to simulation iterations and raise it up. That'll force more calculations per movement as this thing is dynamically colliding with your surfaces. Another thing you can do is come down here to gravity strength and turn that down so it just slows that gravity down. So as it's running the simulation, it's giving it enough time to calculate. So if you don't want to crank up the simulations, turn gravity strength down, you'll get about the same result. Now, another thing to consider is you can go in here to BTC, and that's transpose cloth. And you can actually move these things in space, and with your transpose brush, as you're coming down, it's going to collide. So I can go through here, I can rotate, I can scale, I can push and move these things around, and it's going to automatically, as every single movement, you see if I sit here and wiggle, it's going to start, these edges are going to start separating from each other. If I come in here and crunch it all together and then I start wiggling the mouse, those edges are going to want to start separating, because what cloth wants to do is maintain those edge relationships. And that's what those calculations are trying to accomplish. So having said that, this also applies to speed. We have simulation iterations at 100, and if I go really quickly, you're going to see I'm getting that kind of stretched result too, because I'm moving so fast, the calculations aren't having time to kind of go, hey, let's kind of keep it together a little bit. It just doesn't have time to do that. Same thing if we hit Q, and then we do like brush BCK for the brush cloth hook. If I go through here, and I'm tap S to make my draw size, then you just grab that, or you make your draw size bigger up here. If I go through here and start moving this around and I move it slowly, it'll have plenty of time to simulate and maintain those edge relationships as I'm colliding with these surfaces. Now another calculation to add is also the self-collision. You're going to see as I'm dragging this around, it's kind of colliding with itself and overlapping. The cloth is kind of bunching up here. Also, you can go up here to self-collision and crank that up, and now it's going to be more aware of itself. It's going to increase the complexity of those calculations, but you're going to get a much nicer result. And if you move your brush slowly enough, it'll give it plenty of time to calculate those relationships and collide and do self-collision. It's thinking about a lot of things at once, so you want to give it time to develop and maintain those relationships effectively. If you go through here and you're like, whoosh, and you just kind of pull through, you're going to see it just went right through that collision object. Or if you go way over here really quickly or pull this out really fast, you're going to see we're getting some really nasty stretching along here. So you can do that and it'll let you, but you may be better off kind of just pulling, and you're going to see it's going to want to pull back against you if you go slow enough and it's able to calculate, hey, you know what? We don't necessarily want to allow you to stretch this thing too much. Now you can let it. You can just go through here and just pull and get all sorts of crazy stretching if you want. But another way to combat that is, again, we're not using gravity. We're just kind of pulling this thing along. But you can go up here to simulation iterations, and now as I move this through, I can move really fast and it's still going to maintain those relationships pretty good. I can't move it fast enough to really stretch it too much. So that's another way you can kind of, again, ensure that it's going to maintain those edge relationships between each other.